Signal Sciences secures the most important web applications, APIs, and microservices of the world's leading companies, protecting over 7,500 applications and 150 billion production requests per week. Signal Sciences Next-Gen WAF and RASP help companies increase security and maintain site reliability without sacrificing velocity, all at the lowest total cost of ownership. Signal Sciences patented technology protects any application against any attack with integrations into any DevOps toolchain. Signal Sciences, demand more from your WAF. Learn more at securityweekly.com/Signal Sciences. By connecting to your code repository, Accurix generates a topology across your full stack to reveal risks so that you can harden your architecture. It also scans code for violations against compliance and security standards to enforce best practices. In addition, Accurix develops threat models using vulnerability feeds, IAM privileges, and other data to predict potential breach paths. Learn how easy it is to get started with Accurix at securityweekly.com/Accurix. Discover a simple way to secure your app without the need for a full security team. With trusted software, simply drag and drop your app and let the ML-enabled smart security work. Get it back fully protected within a couple of minutes. With 50 years of security expertise, Erdetto protects over 5 billion devices and applications for some of the world's best-known brands. Change the world one app at a time. To download the white paper on how to address endpoint security in mobile apps, visit securityweekly.com/Erdetto. As the world of software-driven everything becomes a reality and development cycles speed up, sales teams are taking a new approach to application security, one that enables security teams to scale by empowering developers to integrate security into their development workflows and toolsets, all while giving security teams the visibility and control they need. Snyk helps software-driven businesses develop fast and stay secure with a developer-first solution that seamlessly and proactively finds and fixes vulnerabilities in open-source libraries and containers. Learn more and see the solution for yourself at securityweekly.com/Snyk.
Welcome back to Application Security Weekly. I'm your host, Mike Shima, joined by Matt Alderman and John Kinsella. We are looking for high-quality guest suggestions for all of our podcasts to fill our Q3 recording schedule. Submit your suggestions for guests by visiting securityweekly.com/guests and submitting the form. We review suggestions monthly and will reach out to you once reviewed. Learn how to keep your internet self safe in our next webcast on August 13th. Register for our upcoming webcasts or virtual trainings by visiting securityweekly.com/webcasts or visit securityweekly.com/on-demand to view our previously recorded webcasts. So we will get to the Twitter attack, but I want to give Matt and John another couple minutes to gather their thoughts and learn about it. So let's instead first talk about Clifford the SIGRed dog. This is a vulnerability discovered by Checkpoint in the Microsoft DNS stack, dating all the way back to Windows 2003. So a 17-year-old flaw. And basically, what's really cool, two things that are cool for this. One, we're back to protocols. So this Checkpoint write-up is actually quite the journey through RFCs and through the thought process of the Checkpoint developers. So that's researchers. That was really neat. And they basically identified a particular type of DNS query that had a response that could be exploitable as long as you also tied together some compression algorithms to basically deliver a larger than expected payload. So it was a lot of really interesting work, a lot of things that they put together. And between the protocol and the compression aspect, those are really what stood out for me at the beginning. I don't know, Matt or John, what highlighted, what stood out for you in this particular one?
Well, I was thinking about Paul's UDP joke. Did you get it?
We're just going to keep the rest of the podcast silent right there.
I wasn't going to bite.
Well, we'll just end that on a handshake and keep on going. So next up, John, what was your, you've got to have some comment on here.
Yeah, man, he knocks me off my game. I forgot what I was going to say, I have to say.
Well done, Matt.
I totally forget. We'll get back to it. Keep going. It was an interesting one, right? You know, actually, what I will say, what was interesting about this write-up is I was actually showing it last week to not even Linux people, because when it first came out, I'm like, oh, this is bad at CVS has 10 in DNS in Windows. And they're like, no one runs Windows DNS, Linux folks. And I'm like, no, have you heard of Active Directory? And then the BSD guy goes, no, I don't know, no idea what you're talking about. So I pasted over this this link to this write-up, and he's like, that's really well done. Like I'm completely outside the security space and the Windows space and the DNS space, and I could still get it. Oh, I know. My joke was going to be something around Silicon Valley and lossless exploits instead of lossless encryption. Go ahead.
Well done. I did, and I'm glad you're highlighting the write-up too, because that's one of the things that absolutely stood out for me, especially too. There's one section there just describing a very basic threat modeling and the attacker thinking, because they decide. I'm going to read it real quickly from it. There were two main scenarios that they were looking at in this attack surface. It could be a bug in the way the DNS server parses an incoming query, or a bug in the way the DNS server parses a response for a forwarded query. And they point out DNS queries don't have really a complex structure. So they said, well, that first scenario might not be that profitable for us. So they decided to target functions that parse incoming responses for forwarded queries. And obviously they were successful. And their journey does take them through a couple different of the RFCs as they're figuring out and unraveling what this very ancient DNS protocol is. And you can kind of see that the protocol has some layers and layers of some new concepts, new techniques, because the SIG0, the SIG, is basically signed. It's a way of authenticating or signing queries to ensure what the provenance came from them. But there's a lot of the DNS RFCs that have less than ideal security properties, we'll say, both in terms of either encryption algorithms that are suggested or that are chosen, or a lot of competing aspects and ambiguity within the protocol itself. And there was another, if I can scroll up in my notes here, there was another thing that was about this, that essentially the SIG0 capability, part of DNSSEC, is really focused on one very specific capability to authenticate queries, and it's not supposed to be used for other scenarios, and encryption isn't supposed to be used, or encryption has to be carefully used in other areas. So I think the other thing that stood out for me was encryption is important, but has some gotchas to it. And in this case, encryption and compression has always been a danger. We've seen that in the past with OpenSSL and encryption weakening the capabilities of the confidentiality properties of the encryption. And in this case, just with the way that packets are reassembled when they're switched over from UDP to TCP is a good callback to Matt's opening joke. The way that those packets are stitched together is partially what introduced this problem here, which was what was essentially a standard integer heap overflow.
I think the challenge for this thing now is, even though the patch is out, how do you effectively get this thing rolled out to all these Windows machines that are no longer sitting in your corporate environment? So, I think the one challenge here is this is a pretty critical vulnerability with, I think, some difficulties in getting it closed out quickly. I mean, the patch was only released last Tuesday. How quickly will this get out in the environment before somebody exploits this even more? So it'll be interesting.
But that shouldn't be too big a deal here. This isn't an endpoint issue. This is on the server side.
Oh, so, is it on the server side? Oh,
yeah. So it should still be within that purview. But I mean, still, this is a patch like this. Every org is going to test the hell out of it, hopefully, and it's still going to be a good amount of work to test and roll out and all that type of thing for those who do that every month with Windows Patch Tuesday.
Yes.
Patch Tuesday.
Now remote Patch Tuesday.
Nothing like a patch killing your connection.
Guys, it's not like DNS is important for anything. You're right. Yeah, exactly.
No, not at all.
Well, that's partially why I saw SIGRed here, and because of the impact of this, I always have horror movies in the back of my mind, and there's this great giallo horror by Dario Argento called Profondo Rosso, which translates to Deep Red, which I really wish this vulnerability had been branded as such. So if you have a new 0-day, a new vulnerability you want to announce, and you need some branding advice, talk to me, and let's make sure we have some good horror tie-ins. Because of horror tie-ins, I think that's time to bring us into, drum roll for it, I can't do a drum roll, sorry. We'll just say Twitter. So Twitter was in the news because everybody could see an attack unfolding in real time, which was essentially the way it was unfolding. Some select, very highly visible accounts were essentially saying, I want to give back to the community. And for those of you keeping track at home, you could see a very simple con unfold, saying, here's my Bitcoin wallet. In the next 30 minutes, send me a Bitcoin and I'll send you back double. So the reason I point this out as a good con is that it was ostensibly something that would make sense. These were, high-profile accounts and from some billionaires or some people that actually did talk about Bitcoin in the past. So there's a little bit of a little bit it could make sense, but it's setting up It's setting up a sense of urgency. So only the next 30 minutes, and it's appealing to a little bit, or more than a little bit, to greed. Send us 1 Bitcoin or send any amount of Bitcoin, and you'll get double back just to improve the community. So that was how the attack was. What we saw it unfold. But of course, behind the scenes, there were a lot of other things happening. So Matt or John, what do you want to dive in? What aspect do you want to dive into first here?
Well, I have to make one comment. I mean, Trump just has to be happy that his account basically got locked down by Twitter because he didn't get hacked.
Yeah, and Jack even came out and say, between Jack and Trump and there are some other select accounts, there are definitely some more manual controls in place for approval for anything that needs for any change that will be made to this. And that is going to touch on some other things I want to get into. But John, I want to get your feelings about this too.
Yeah, I really don't care. I think, and sorry for the bluntness, it was interesting what happened. I was on mute, so you couldn't hear me sniggering and cackling when you're talking about people saying, hey, give me money and I'll double it. Come on, people.
Yeah.
But then, the one part I stopped paying attention to it last week. The one part I'm actually curious about is going back and reading the Krebs article or whoever else around who actually did it. I mean, we can probably guess, but usually those sort of, when Krebs goes back and starts tracking folks down, that's when things get interesting.
Yeah, and I think, so for me, what really stood out here, and I think what was more interesting to talk about, is actually what's the AppSec and the DevSecOps angle here, and because that, I think, is what is more universally applicable, because we can't make fun of the fact that Bitcoin is a bit useless anyway for buying anything, and so yes, it was just an appeal to greed. But in this case, the AppSec parts here is that I often go back, I think it was early 2000s, Microsoft Research introduced this concept of a ceremony. And essentially what a ceremony is, it says, let's talk about a protocol, but if humans have to be part of this protocol, meaning they have to do a key exchange, or they have to figure out how to generate the secret key for a public-private key pair, and you want to make sure you have a lot of people and minimize the chance of collusion or minimize the chance that that secret key is leaked because it might underpin your DNSSEC deployment, they introduced this idea of a ceremony saying that people are important to this protocol. And where I'm going with this, if you haven't read about how this hack was ostensibly pulled off, was essentially social engineering against customer support. So Twitter, like many other systems, has a customer support capability so that if someone calls in, they can help them with account recovery. And account recovery remains a very difficult problem because you can't just say use YubiKeys or use hardware tokens to protect your account, because once you lose that, you potentially completely lose access to your account. So depending on your threat model or depending on your level of sensitivity, you're either someone like Google Advanced Security for Gmail, where they'll say, give us a couple weeks and maybe we'll figure out how to get you back in once we confirm your identity. Or in this case, talk to the customer support team and they'll figure out either how to disable temporarily the 2FA, change the email, which of course the email is your identity anchor. So that's where the AppSec aspect comes into me, and I think is more applicable for a lot of companies that are building these types of applications.
Yeah, and that you're completely fair in that. There's a few things there, and also about that. The one thing that sort of caught my ear was about that admin interface, which I guess did screenshots get out? I guess there might have been screenshots. Mm-hmm. That's sort of, again, another sort of core area of the AppSec side of this, of like, what okay, at least they're doing the right thing, and the admin interface is a separate application from the public Twitter interface. Mm-hmm. But that's, what do you do there? What do you allow people to have, and RBAC and those type of things. So I think, yeah, from that point of view, it's interesting to talk about.
And there's also an aspect too. This isn't directly related to, I think, to the hack, or we don't have the details yet. But Twitter is already demonstrating some good transparency about it. Their Twitter support and their blog talking about it. So this is a good thing that I think, as we mentioned before, we should continue to encourage. In the last episode, I'd also mentioned about Oauth tokens and handling them. What it sounded like, at least from my initial reading, is that an attacker possibly obtained a token or obtained access to an internal Slack, where again, then credentials were being posted to some of these internal tools, if I did read that correctly. So it does both point to, making sure that you can have 2FA enabled for a lot of your access, but the tokens that are granted once you've proven your identity, those are tokens that still grant access. And those types of tokens are the best backdoor ever into a system, because those are valid credentials. So there's that one aspect there to keep an eye on, as everyone is now working remotely, as well as any of these systems or any of these accounts that were compromised. In addition to going back and determining, were DMs read, resetting back to their emails, it's also be important to reset every single Oauth token for an integration with any of those third parties, because that would be a great way to have persistent access to these accounts if those weren't changed. So there's some important things here as well from that AppSec perspective to keep in mind. So this didn't just apply, the attack applied to Twitter, but the concepts, I think, are pretty universal.
Mm-hmm. Yeah, and it's an interesting attack vector on social media, but we've seen other types of attacks like this. So it's a new medium, which means any of the potential social media platforms are susceptible to something similar to this. Any system like Facebook or any of these others that have a way for employees to get in with an admin interface could potentially do the exact same thing.
Yeah, and I linked as well too. There was an article, a bit older one, from the NCSC. So this is from the UK government that had some guidelines on social media, and it's more focused for organizations. And it has some good advice about making sure only authorized staff can publish content. Use a bit generic, saying use platforms that provide good security features. Okay, that's a bit generic, but that means two-factor auth. But there's also a point here about make sure content can be reviewed and authorized before being published. And that review and authorize speaks to a little bit of that ceremony that I was kind of alluding to earlier, because that's also in the sense of your ops team, your customer success team. If someone is calling in and saying, I need a password reset, depending on either the sensitivity of the accounts or depending on the sensitivity of what current security controls are already in place, that might be a situation where it should actually have two people confirming a change. So for example, if John and I are working customer success and Matt calls in, needs a change, if I'm going to disable 2FA for that account, it might be a good thing to consider this is a sensitive action. Maybe a second person should review this. So John should check that over too. Obviously, there are scaling problems here and things to consider, but these are good threat models to go through. So your product security team can have some, I think, good conversations about what still remains technical issues, but are more about the people aspect of these technical, how they fit into these threat models. And so let's see what else. So I don't know that there's, so those are the main points I wanted to make on about that Twitter hack. And yes, we can go and snicker about everything else, about what was pulled off and everyone else second guessing and doing armchair about what they would have done different in terms of the attack itself. But I think what's more important, especially from AppSec, is what do you have to suggest to make this type of resilience better or account recovery, as well as what would you do in terms of user notification. So if, for example, the email is being changed or 2FA is being removed, that's also probably a good thing to engage the user and say, send them an out of band message to that email account and say, this email has been removed. And that way you also can engage the user to be that alerting mechanism. So that was, I think, the one final thing I wanted to add on this aspect.
And I think you're I don't want to say
you can say I'm
fair,
right. Go for it.
No.
Come on,
Yeah,
John.
you are right to bring this up. Damn it, I had to say it.
Phew.
But a lot of our listeners are probably getting asked by their management, how do we make sure this doesn't happen to us, right? And so it's definitely worth talking about it. I don't want to just make it seem like I'm blowing off the whole thing. You're bringing up all sorts of interesting things I don't want to sidetrack on, like with the where's my brain? Having the stuff for the certificates having like some sort of human interaction. But I think if folks who are listening to this or anyone out there if you put that time in to stop and just think about this and think about what we're thinking, and you have that thought process when you go to build an app like this or the app you already have internally. I mean, the biggest thing I've seen in the past is, internal folks probably don't want to do some of the things you're talking about, Mike, from the 2FA tokens every time they log into their internal stuff. And, in some organizations, getting that 2FA token is, takes a jumping through quite a few hoops. And maybe you want it on a Friday evening. So I think there's how do you deal with those type of things? How do you deal with them ahead of time? I think that's definitely something for all of us to think about.
Yeah, good things to think about. And if you're just saying, I'm saying this as in general, if as a security team you're just hand waving away, well, humans are the weakest link, and you walk away, I'm going to say that's actually a pretty lazy approach, and there's a lot more you could be doing. So use this attack to do a sort of pre-mortem, as it were, for your own systems on your own products, and see how it could apply to you. So with that, perhaps we've spent more than 240 characters or 280 characters on that. So let's move on to another news article. And this one, I think, also caught your eye, Matt, about Google and confidential computing. So maybe what exactly is confidential computing?
Yeah, I thought this was there's two announcements from Google Cloud this week on assured workloads for the government and this confidential VMs, which I thought was a little more interesting, actually, because supposedly what this is going to do is allow you to have encrypted VMs in your data so that it protects the privacy of the data. And it's a default configuration that's going to be available on Google platform to allow these confidential VMs to be spun up. Interesting concept. They expanded that a little bit with this assured offering for the government, because they're also trying to figure out how to go after some of these government cloud contracts. And they added some additional capabilities like pinning data and data location and default secure configuration. So Google's making some, Google Cloud is making some very interesting improvements from a security perspective. This is one of the things that I thought Google could have done a long time ago and really would have differentiated them over AWS and Azure in the cloud wars, right? Is come out of the box with just some secure configurations and use security as kind of your wedge to get in. These two announcements kind of are showing you that they're starting to go down that path, which I think is encouraging.
Yeah, this is an interesting one. I was putting a pretty good amount of research into this confidential compute stuff at the beginning of the year, and I'm not sure if I still am. I'm supposed to give a talk in the fall about confidential compute. We'll see where that goes. But what's interesting about this, because in our internal notes, I was like, when someone had going through the press release, Google saying we're the first major cloud provider to offer this level of security and isolation. Like, what? Because Amazon's had this for a while. Azure's had this for a while, but when you take a step back and actually look at what they're doing, Matt, it's not just secure by default; it's usable and easy security, and I think that's interesting here. And I'm still trying to wrap my head around some of the ramifications of how they're doing this. So the other two guys are using Intel SGX, which has been around, and I don't know if you did answer that question, but for folks who don't know what confidential compute is, the ability to basically run your application in someone else's cloud without either that provider or someone else on that same system being able to access your data, even if they compromise the system, right? So that's really the end goal here, is to be fully secure and confident in what you're doing on someone else's system. So on Intel, you do it through SGX, it's a long process. We looked at it at Layered Insight, where you basically have to get Intel has to sign your code, so then when your code runs in the Intel CPU, it's able to validate the signature on there, and you run in what's called an enclave. But what's interesting here and what's easy about what Google's done is they're using the AMD EPYC chip series, which are using a technology they're referring to as, is it SEV.
SEV.
And what they're doing, which is interesting, is it's not just the enclave which is secure, but it's that whole system. Once it's been blessed, that machine is got encrypted memory. So it's sort of a very quick wipe your hands, and in theory you're secure if this stuff actually holds up and they don't find a bunch of CPU bugs. But what's interesting now, let's take a step back real quick, Matt, from what you're talking about. Historically, the folks that go after what we did at Layered Insight and that go after confidential compute, all these type of really heavy, higher end security concepts are usually, the banks or the governments or people who actually really, really care about their stuff being secure, right? It's not going to be the lemonade stand or maybe some of the stuff at Twitter, but it's a lot of the stuff out there is not going to be even looking at it. But when it's as easy to do as what Google's just made it, that's really interesting. Where I'm having the problems right now is, does that mean that all the other providers have to switch over to a specific brand of CPU to do this, or are they going to be able to figure out a way of doing this within SGX? So I think that's sort of interesting to chew on.
Yeah, I mean, it brings up a very interesting component of Intel and SGX and the future of Intel, which is kind of a side tangent, right? Because you see Google moving away from the Intel chipset to actually deploy this with AMD. And so it puts them in a unique position that maybe Microsoft and Amazon are not in with their relationships with Intel.
Yeah, especially with Apple also moving away from Intel as well.
Intel as well, yeah.
I think another thing that stood out to me was there was also part of this announcement, what's underpinning this from Google Cloud is also their open source project that they released called Asilo, or asilo.dev is where you can find it. And what appealed to me was that in this case, one, it's C++, which my heart of hearts, I will always love C++. So thumbs up for that. But that is an implementation detail. But we'll save Matt later. Sorry. But what was neat is that they actually showed some examples of when and how you would use this on things that are actually pretty relevant. So this wasn't just a hello world, here's how to use a silo. Here's how to use it with gRPC to have very strongly, basically hard pinned to trusted hardware, essentially, in these enclaves, authentication and authorization with gRPC calls. So that's a really compelling story right there. And the other thing they're also showing is that you can effectively run something like SQLite out of the box as a wrapper with this. And so again, they're both, one, demonstrating the capability and saying that this is actually usable in the real world. So you don't need the large engineering staff or the large security staff and investment that you have from a company like Google that only another, I'll count on probably one hand, another couple of type of organizations have. This potentially could be usable for others. And to your point, John and Matt, it'll be curious to see, is this adaptable to the other enclaves or not? And I will have to admit, I'm going to have to do my own hand waving away. I have no idea. I didn't do enough in-depth research there to see what the future holds on that angle.
It's interesting because one of the things when I was doing research earlier, I was looking for, there's some folks out there that are trying to do confidential compute without hardware support, which is obviously sort of tricky, right? So I think there's some open source projects in that area that would make this a little more portable. Obviously, if you can do it in a chip, but then the problem with the cloud providers, they only turned on being able to access this in the last year or so. And some of the smaller providers probably still don't have it yet. So it's still, I mean, it's interesting to think about. It's not quite fully academic, but you probably have another year or two before I think this really starts getting popular, is my guess.
Indeed. And as speaking of another year or two, as we're coming down to the end here, I did pull up, there was another article that is, no, that's coming next year, I think. That's coming with Linux on the desktop,
Yes.
native IPv6 support. But no, this was IoT. So we haven't found any good aerospace IoT for you in a couple weeks. So listeners, if you're in our Discord, please start, go out, find some articles. Let's get some aerospace and AppSec for John and keep him engaged during these segments. But I did still find an IoT update, and this was actually a callback to episode 93. There was some rules coming out of the the UK again, actually, that was looking to say, how can we perhaps regulate IoT? And it was calling out three basic things, saying device passwords should be unique and not resettable to any universal factory settings. Manufacturers have to have a point of contact for reporting vulns, effectively have a bug bounty program of sorts or a vulnerability reporting program. And the device, there has to be some minimum length of time that the device is going to get security updates. So those are pretty simple, pretty straightforward. What's interesting is that there's a lot of discussion still going on about should those still be the things that are regulated? And more importantly then, well, so what? What would the consequences be? So it's an interesting area to watch, and because that might, what happens in IoT, there's consequences and regulations already we've seen around privacy. So be curious to see what else might unfold in response to something like a Twitter attack or other types of attacks that we see over the next coming years.
Yeah, this one came out early in the year as a guidance out of the UK. And I think now what they're doing is moving it to the point where they're going to put this in place. What I like about this regulation, the requirements are pretty simple, right? You laid them out.
Right.
But if you don't meet them, you can't sell your consumer IoT devices in the UK. That puts a cost associated to the suppliers for this, right? They could literally get locked out of a market. I think it's a really interesting incentive base that says, look, here's the requirements. You either do it and you sell your stuff in the device and we give you access to our market, or you don't do these things and we'll just block you out of the market altogether. It's a really interesting incentive program. Now, this is really on the more on the consumer side than aspects of industry or other types of IoT devices. It would be interesting to see how other people leverage this approach in some of those other areas.
Yeah, and even we even talked about some of the economics of security and incentives, I think, just in the last episode. So listeners, if you missed that one, go back and listen to it, because there's a bunch of interesting things there that ties in, Matt, to very much to your point, looking at where are they pushing the burden for this? And if you have a security hat on, thinking, is the burden and are the burden and incentives well aligned for the outcomes that are being desired? And so far, it perhaps seems like it might be.
Yeah, I mean, this is the general problem we've discussed on Security and Compliance Weekly. Having spent a number of years on the compliance side, there has to be an incentive-based model, I think, for regulations to work well. And the example I always give is Gramm-Leach-Bliley. In the early days of Gramm-Leach-Bliley, the incentive was banks got to do a whole bunch of more stuff by repealing the Glass-Steagall Act. There was an incentive for them to put these security controls in place and to protect the privacy of the banking customers. When you took something like a HIPAA in the early days, there was no incentive. And enforcement was also kind of on the mismatch. What the UK has done with this IoT is they've created an incentive for consumer IoT vendors to play in a market. So there's an upside to actually meeting the requirements. And I think that's why you have to think about regulations to be successful. There has to be an incentive for it to work well.
There's an interesting story here. See if I can keep it quick. There's an interesting thing going on that I'm noticing in the IoT space. You've got sort of the big name retailers, right? The Nests of the world, the people who have probably some level of VC funding. I think let's say it that way. Those guys, if regulation happens, they're obviously going to have to do this stuff in the morning, right? So they're taken care of, and they'll put the effort into it. The smaller sort of underneath the radar Chinese, third shift factories or whatever they are that are working out some stuff and cranking stuff out. They're not going to follow. They're not worried about getting fined, but they are interested in selling their stuff, and they're really caring about how I say the economy of this and how it scales. So the example I want to tell the story. I've been playing with a little IoT board. It's a relay with an 8266 plugged into it on a little 8266 module. And when I first got it, I flashed Tasmode onto it as an open source firmware. I'd go and click to turn on and off the relay in the Tasmode, and it would do its thing on the 8266 fine, but the relay wasn't clicking. And it turns out there was another microcontroller by the relay, and that was controlling the probably an isolator and then the relay itself. But that thing was getting its instructions from the 8266, which was just purely doing Wi-Fi in this case. And the reason I mentioned this and where it's interesting is that other microcontroller, you turn it on and off using AT commands. Remember those from the modems back in like the 90s? I'm not making this up.
AT/DT. That's awesome.
Yeah. So that's how you turn this relay on and off, is with AT. And so as I went around looking, I'm like, that just seems too hackish. Let's see if I can find a vendor that does it something different. And there was a bunch of vendors out there that are making various different relay boards using this silly little microcontroller. And the reason I'm saying that is it comes back directly to this sort of use case. If we can get some of those firmware writers, whoever wrote that thing in the first place, to start thinking about actually putting some of these controls and firmware update, not the update itself, you can just give us hooks so we can do it, right? So like a Qualys or whoever else can go and somehow update the firmware on that, or work with a third-party vendor. You get the idea. So hopefully we'll get down in that direction. They're really driven by what people buy. So cross our fingers and see what happens there.
That's awesome. Well, I was able to sneak in, once again, a reference to a horror movie and Dario Argento. And since you mentioned AT commands, we'll say if you want to see AT commands in action, check out War Games, because they're you'll see some actually show up on screen, because there is some modem dialing. So thank you for that story, John. And we're definitely going to have to find some good more IoT articles for you. So I want to thank John once again. I want to thank Matt. I want to thank everyone for listening this week. We want to thank everyone for joining us. We'll see you again next week on Application Security Weekly.